Today we'll be working on lesson 3.2, graphing quadratic functions, and this is going to be 3.2a. We're going to be discussing two forms, which are the vertex form and the root form. So let's start on number 1. Now, what do you think this is written in? Vertex form or root form? Now, since you are able to get the vertex right from the equation, and it's written in the form a x minus h to the second power plus k, so that's the general form of the vertex form. So as you can see, h in this case is going to be 4, and the k is going to be the number on the outside, and since we don't have a number on the outside, the k is going to be 0. So my vertex is going to be 4, 0. So let's plot that. Now, remember, to be able to graph a vertex form or any quadratic equation, you just need a vertex and the a, because these will tell you the pattern that you will use to be graphing your quadratic equation. Now, as you can see, the a in this case is positive 1. So it's going to be a parabola that opens upward, having a vertex that is a minimum. Okay? And since your vertex is 1, then the pattern is going to be 1, 3, 5, all the odd numbers, okay? So we're going to start with our vertex, and since it's a minimum vertex, it's going to be opening upward, so I'm going to go up with the pattern 1, 3, 5. So let's see how we do that. Starting from the vertex, you're going to go up 1 over 1 always. So, and then from that point, you're going to go up 3, so 1, 2, 3, over 1 always. And then from there, you're going to go up 5, so 1, 2, 3, 4, 5, over 1 always. So that's going to be the right side of my parabola. Now remember, every time you have a parabola, you have something called axis of symmetry that goes in the middle, that cuts the parabola in half. And the right side and the left side always overlap if you try to reflect it across the axis of symmetry. So this is going to be called our axis of symmetry. And it's going to be the vertical line going through the vertex. So it will have an equation of x equals to the x of the vertex, and which in this case is 4. Now, since we have the axis of symmetry, I know all the points are going to reflect. So I'm going to have a point over here, another point over here, and another point over here. So that's going to give me the left side of my graph. Now, if you're asked to create a table, you can pick up the points from here and fill your table, okay? Now, what are the roots in this case? Now, the roots basically is where the graph touches or crosses the x-axis. Now, as you can see, my graph touches the x-axis only in one point. So that's going to be my x-intercept. So my x-intercept is, in this case, the vertex. And since your graph is bouncing off the x-axis, we said that this is going to be a double root. So we have a double root over here. And remember what we said, there will be a multiplicity of 2. And since you have a power of 2, so the root 4 is counted twice. We're going to cover this again in polynomials and rational functions, so it's good to know it, but we're going to cover it again later on. So in this case, my root is going to be x is equal to 4. Now the y-intercept is where your graph touches the y-axis. Now as you can see, you were not able to tell that from the graph because it seems like your graph's going to touch the y-axis somewhere outside your coordinate plane, the one that you have over here. So what do we do in this case? In this case, I know if I want my y-intercept, it means I know that the x is 0. So what you can do is you can plug in 0 for x in the equation. As you can see, you plug in x equals 0. In your equation, you solve for y. So y is equal to negative 4 squared, which is in this case 4 squared, which is 16. So my y-intercept is 0, 16. So that's how you do, or you graph a quadratic equation if it's written in the vertex form. What if it's written in a root form? So as you can see, the second part in our practice sheet is going to be a root form. So what is the general equation of the root form? It's y equals a x minus r1 and x minus r2. And the reason why this is called a root form is because you're able to get the roots right from the equation. So in this case, my root is going to be 5, just 5. So I'm going to write 5, 0 over here. I'm going to write x equals 5 over here. Do you know why? Because if you look closer at this equation, you can see that you can write it as y equals x minus 5 to the power 2. So it's a vertex form at the same time. So you can see that you can really, if you have something like that, you can write it either in vertex form or root form. So what I want you to do is try to do this on your own. It's the same as number 1, and I'm going to move on to number 3. It's a little bit different. So let's try to graph this one. So as you can see, it's written in the vertex form. So my h is -1 and my k is -4. So my vertex is -1, -4. Now why is the 4 looking like a y? Okay, so -1, -4. So that's going to be my vertex. Now since my a is 2, and it's positive, so it's going to be opening upward with the vertex of a minimum. And since a is 2, remember the pattern before was 1, 3, 5 when a is 1. So when a is 2, you multiply them by 2, so it becomes 2, 6, 10. So from the vertex, you go up to 6, 10. Let's make this bigger. So remember, you have to go up 2 over 1 always, and you can reflect it. And then from that point, you need to go 6 over 1 always, and you can reflect it, and so on. So I think this is enough for me to graph my parabola, because the other point is going to be outside my graph or the grid that I have. So that's going to be my vertex, and that's going to be my graph. My axis of symmetry is going to be the one in the middle, cutting it in half. So my equation for the axis of symmetry is going to be x equals to -1, since it's a vertical line going through the vertex. Now, what would be the y-intercept? The y-intercept, as you can see, is where the graph touches the y-axis. In this case, it's -2, 0. Now, what about the x-intercept? As you can see, your graph goes through the x-axis twice, but it's not going through a pretty point, so there should be always a plan B to solve x-intercepts if they are not pretty points. To do that, you have to think that the y of the x-intercept is always what? The y of the x-intercept is always what? The y of the x-intercept is always 0. So what you need to do is you need to plug in 0 for y. This is how you do it algebraically, okay? So you plug in 0 for y, and you try to get the x. So basically you need to solve for x. And you do this algebraically if the x-intercept is not a pretty point. To do that, you have to isolate the parentheses or the x. So you need to add 4 to both sides. So you have 4 equals to x plus 1 square. Then you need to divide by 2, both sides by 2, to isolate the parentheses. 4 divided by 2 is a 2. Now from here, you have to get rid of the square. How can you get rid of the square? By square rooting both sides. So in this case, the square and the square root cancel out, so you end up with an x plus 1 equals. And remember, every time you square root a number, you're going to end up with a plus or minus square root of 2. And the reason why you end up with a square root of a positive or a negative square root of 2 is, think of it this way. If I'm square rooting 4, what do you think I should get? Plus or minus 2, because if you square 2, you're going to get 4. And if you square -2, you're also going to get 4. So -2 and 2 will give you 4. So when you square root 4, you have to think of both of those answers. So when you square root a number, remember you will always have 2 answers, okay? Now let's move on from here. So x plus 1 will be equal then to plus or minus square root of 2. Now remember, I want x. So x is going to be equal to do that, I need to isolate x by subtracting 1 from both sides. So x is equal to -1 plus or minus square root of 2. This way, you notice that you have two x-intercepts. One of them is going to be negative 1 plus radical 2, and the other one is going to be negative 1 minus radical 2. Now, to check your answer, 2 is almost like 1.3, 1.4. Think of it this way, 1.2, let's say 1.3. Okay, so negative 1 plus 1.3 is almost like 0.3. And if you look at that, your graph is going through almost a 0.3. Now, negative 1 minus 1.3 would be negative 2.3. So as you can see, your point is going through something close to that. So then your x-intercepts are correct. Now, to write that, you have to write the x-intercept, you write negative 1 plus radical 2 comma 0 and negative 1 minus radical 2 comma 0, and that would be your two x-intercepts. Now, as for the roots, you can say negative 1 plus radical 2 comma negative 1 minus radical 2, or you can just write it as negative 1 plus or minus radical 2. It's up to you. I will take both answers. So this is how you would do the x-intercept algebraically if you do not have it as a pretty point. Now let's move on one root with you. So let's do number 6. Now, it's called the root form because it reminds us of the general form a x minus r1 x minus r2, and it's called the root form because you're able to get the roots out of this equation. So in this case, what are my roots? The roots are going to be the numbers inside the parentheses, so in this case they are 1 and 5. So my x-intercepts are 1, 0, and 5, 0. Now let's plot these x-intercepts. So the first one is going to be 1, 0, and 5, 0. Now, remember that in quadratic equation, everything is going to reflect across the axis of symmetry. So if I know that my x-intercepts are over here, then I know that they should overlap if I reflect my parabola over the axis of symmetry. So where is the axis of symmetry? The axis of symmetry is going to be the vertical line going through the vertex between those 2 points. So halfway between these 2 points is going to be x equals 3. So let me draw my axis of symmetry. Then I know that my vertex is going to be on this line. So this is going to be my axis of symmetry. X equals 3. Okay? So how can I find the vertex then? If I know that the axis of symmetry is 3, then I know that the vertex has an x over 3. How can I find the y? To find the y, you need to go back to your equation and plug in 3 for x. Once you do that, the y value that you're going to get is going to be your y of the vertex. So y equals negative 2. 3 minus 1 is 2. 3 minus 5 is negative 2. If you multiply those together, you're going to get negative 4. So negative 2 times 2 is negative 4. You copy the negative 2. So y is going to be 8. So 3, 8 is going to be my vertex. So 1, 2, 3, 4, 5, 6, 7, 8. That's going to be your vertex. Now, as you can see, it looks like a graph or parabola that's going to open downward because a, as you can see, is negative and the vertex is a maximum. Okay, so look at the a is 2. So your pattern for this one is going to be 1, 3, 5. It's going to be 2, 6, 10. So from the vertex, count 2 downward, and the reason why we're counting downward this way because a is negative. So downward 2 and over 1. And then from here, you're going to count 6 downward. So 1, 2, 3, 4, 5, 6, and over 1. And then from here, you're going to count 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1 over. So that's going to be your y-intercept, as you can see, because it's crossing the y-axis. So my y-axis in this case is going to be 0, negative 10. And remember, if you want to fill your table, you just get the points that you just plotted, get the coordinates of these points, and fill in the table. So that is lesson 3-2A. Go ahead and do the rest of the practice on your own and check the answer key on our website.